All right, I guess we're getting pretty close to wrapping things up here. I know we're probably a couple hours in at this point. Um, One last thing that I know I wanted to show you guys before we move forward to the final thing, which is I wanted to show you how to run transactions using React, using a hardware wallet, I should say, through a React application, so that you can deploy your contracts and actually keep your contracts safe on a hardware wallet. That's extremely important in my opinion. All my contracts are on hardware wallets. I want to show you guys how to do that. That's the final thing. Before we get to that, one last thing that I wanted to show you is how to look stuff up on someone else's contract. And I'll give an example here, which is a very, very common one, that probably the most common. I do this right inside the public section, right underneath where I define my data stream here. I'll just, make some space, copy and paste. So, at the bottom, how we defined our tables down here. Well, we're not the only people with tables on our contract, right? Everybody has them. Every contract has tables for the most part. So all we do is copy the exact data structure of the table on the other person's contract. So in this case, this is the atomic assets contract. This is a very common one because people want to look up an asset ID of an asset. You might receive an NFT from someone and react to it by using an onNotify atomic assets transfer. And then inside of that, you might want to look up the asset ID to just verify the information about it. So you can do that by defining the table up here. And now you just refer to that table as atomics T. And by the way, the atomic assets contract is open source. I'll link it below the video, but if you just look up atomic assets contract GitHub, you'll literally find the whole contract. And that's where I got this table from. This is the definition right here. And if I want to look up an asset, all I would have to do is initialize the connection like I normally do. So remember, we're calling this atomics T here. See right here how we look for our own contract or our own table on our own contract. Well, if we were looking for something on the atomic assets contract, we just initialize the connection by saying atomics T asset ID table or something. And then the contract would obviously be atomic assets. And the scope for this is I want to say the username of the person holding the NFT, which in our case, if we were receiving a transfer from somebody, at this point, by the time we do this lookup, we actually are the person holding the NFT. We've gotten it. So we basically just put getSelf.value as the scope. Let me make sure that's correct. Let's go to the atomic assets table, contract, and under the scope, let me put the name of, let's put Mike D Crypto 5. I think I have some NFTs there. Yeah, all right, that's correct. So the scope is you're the person holding the NFTs. So if someone sent you an NFT, an atomic assets NFT anyway, all you'd have to do is initialize the connection, make sure you're looking at the atomic assets contract, you have yourself as the scope, and then now, you know what, I guess I should probably show you a full example, huh? Let's do an actual atomic assets transfer. All right, so this is what it looks like if you're reacting to an atomic assets transfer, and you are getting notified about it, which you would be if you're the receiver of the NFT. I'm just going to put this table definition here on the side for a second. So yeah, the first thing you'd want to do here is just do that whole get first receiver thing again to make sure that it's atomic assets. So let's define the real contract and the original contract, just like we did above in the EOSIO.token one. Real contract, atomic assets. Original contract is get first receiver. And then we just want to check that the real contract equals the original contract. And also we'll do the same thing that we did down here with the return if we are the sender or not the receiver. All right, so now we've ran those basic checks and balances. Now, when this notification comes to us, we're going to run this function that we've called listen here. It's going to take in 4 parameters, which would be the owner, which is the person who sent it, Honestly, let's just call that from again. Name is 2. Then there's going to be a vector or a list of IDs. These are going to be the asset IDs, and then you have the memo. So what we can do is say, first we want to make sure we got more than 0 assets. So we'll say check IDs.size. That's the amount of assets in that list up here. Let's say check IDs.size is greater than or equal to 1. You must send at least 1 NFT. And then we can initialize this connection to the table here. And all we have to do now that we are looking at the atomic assets table and we have the scope set to ourselves, all we're really doing now is checking if we actually hold the asset. So we could just do something like auto asset iterator equals atomics t atomic t equals asset ID table dot find IDs. You know what? We might have received more than one. This doesn't make sense. So if we're receiving a bunch of assets, we're getting a list here. So let's create a for loop. We'll just say for auto this asset IDs This just basically means that we're looping through the IDs and we're referring to each one of them as this asset. So we'll just say asset iterator equals asset ID table dot find this asset. And then check asset iterator does not equal asset ID table dot end could not locate this asset. That just means you didn't actually send this to us, bro, because we just looked at the atomic assets table. We scoped it by our name. We should have the asset if you sent it to us. We're not finding it. So since we didn't find it, that means you didn't send it to us. That's all that means. So let's compile this contract again. We should have probably like 80 errors. Atomic T. Where did I call it? Atomic T. This should be atomics T. Always check your typing. Always check your typing. All right, so that compiled fine. You know what? Let's throw in a bonus here. Let's throw in a bonus. Let me show you how to burn the asset. And because we want to prove that this is actually working anyway, right? Like, how are we even going to know if this worked? So down in the private section, right above these tables, I like to define some functions. So I'm going to define this one. I'm just copying and pasting it from another contract I have. Burn an asset. Void burn asset. All it takes in is an asset ID. Permission level would be get self, active, our own active permission. The contract we're doing it on is atomic assets contract. And the action on that contract is burn asset. And then we just create a tuple, ourself, and the asset ID dot send. So now all we have to do is call this burn asset function in line, so we don't have to write it out. Remember I said before, like, I wouldn't be writing this whole thing out here. Well, this is a way where you can keep it more organized. And now it's so simple. Literally all we have to do is go back up to right here where we're looping through the for loop and just burn asset. And all we have to put inside the parentheses is literally just this asset. That's it. And now this should compile. All right. And now I have to unlock the wallet again. I'm not even going to bother trying. Deploy the contract. All right. Now, as Mike Decrypto 5, let's go to Atomic Hub testnet. I believe it's testwax.atomic hub. Or maybe it's wax test. All right, so now if I go to my inventory, take a couple NFTs, make sure that they're actually burnable. Let's use, yeah, just take a couple of these random NFTs. Take this one, and we'll take this one, and how about one more? And then transfer them to code tutorial. They should all get burned if this works. All right, well, the transaction was successful. And then now let's go back to the code tutorial account. Burn asset, burn asset, burn asset. All right, so we received 3 assets and we burned all 3 of them. And we can verify this by just going to any random asset on Atomic Hub and just changing this asset ID to be one of the ones we just sent to the contract. And you can see that it's now burned. Owner burned. So all 3 of those got burned. And that's basically that. That's how that works. So all that's left at this point, I think, is to show you how to use a React app. I'm not going to go too in depth. What I'm going to do is I have my own kind of custom admin panel that I use on my local machine. I don't have it like on my server or anything where my website is. I just keep it on my local computer, right? So I build this app and it's just like a little panel where I can do some admin actions. I can one of the main things that I do is deploy my contracts from there using a hardware wallet. So what I'm going to do is I'm going to turn that, I'm going to strip some of it down and get rid of anything, personal or whatever. I'm going to make a very boilerplate kind of template version of it. I'm going to put it on GitHub and I'll show you guys how to basically set it up and install it on your computer. And then I'll show you how to modify the transactions just to work for you, so that that's that. All you really have to do at that point is compile your contract, get the WASM hash for it, the ABI hash for it. You might not understand what either one of those things mean, but it's very simple. You just press a button, copy and paste a string into a function, and then you create the transaction. It's real simple. I'm going to show you guys how to do it, and that's probably going to be the final part of the video. So that is coming up next.